it to the TA.
Yes, Professor, we got it.
Okay.
Huh?
We already got it
Who
for
are not, yeah. I gave it to the TA, and you guys should be able to see that. Plus, who are not attending the classes regularly will be reported. That's the requirement from the registry. Okay. That having said that, I'm gonna share my that last. Yeah. Can you see the screen? Hello?
Yes,
Yes, Professor.
Yes, Professor.
Okay. So the way this econometrics is arranged is you first start with an economic theory, okay? Like absolute income hypothesis of John Maynard Keynes, where John Maynard Keynes is saying if income increases, consumption also increases. However, if income increases by $1, consumption increases by less than $1. That's what the economic theory is. That is starting point. Then what you do is you try to write it in some equation form, some mathematical function. The economic theory, you translate it into a mathematical function. Then mathematical function obviously can be of different types. We assume the simplest possible one, which is a linear function. So x, which is our income, is the independent variable. Y, which is the consumption or consumer expenditure, is the dependent variable. So we're saying the dependent variable consumption or consumer expenditure linearly depends on income. A linear function is written where so the equation is y equals beta 1 plus beta 2x. It's not minus, it's plus. Beta 1 plus beta 2x. Beta 1 is the intercept, beta 2 is the slope. Beta 1 has an explanation for this particular example when you are talking about this Keynesian consumption theory. Beta 1 is the intercept. Also in this example, it's an autonomous consumption. Beta 2 is the slope, but it has another explanation for this particular example. This is marginal propensity to consume. But all usual explanations of intercept and slope remain. dy dx equals what in this example? Dy dx. Hello? Hello?
Yes, Professor.
What is dy dx here?
Beta 2. Beta 2. Minus beta 2 or beta 2?
Minus. Where do you get minus from? What did I say?
I
You
can
listen
say
to what I said?
minus. Yeah.
Huh?
Yes, Professor.
Is there a minus? No.
In the screen, I can see minus.
Beta 1 plus beta 2x. So what is dy dx?
Beta 2.
Beta 2. What is it telling you?
It is telling that if X increases by $1, then Y will increase by beta $2.
Y will increase or decrease?
It decrease.
Decrease. Why? How do you get decrease from?
Increase.
Are you guys listening to what I say?
Yes, Professor, it will increase, right?
Y will increase by beta 2
Units.
dollars.
Professor, I have a question.
Yes.
In the screen, I can see Y is equal to beta 1 minus beta 2X.
That's a typo. That's a
Oh.
typo.
Okay.
Okay.
Yes.
That's a typo. There will be many other typos in this, but I'll tell you the right one. Okay. Then we said so here you show the intercept, which is autonomous consumption. Here you are showing the slope. This is not, again, this is a typo. This is not beta 2 minus MPC. This is saying beta 2 equals MPC. Beta 2 is the slope, which means MPC for this particular example. For this particular example, this is marginal propensity to consume. We talked about that a lot. Then we said there is no exact relationship. This is an exact relationship. Y equals beta 1 plus beta 2x is an exact relationship. However, if we look at the data, we will see that there is no exact relationship. So we add one extra term, U, which is called a disturbance term or error term or random term. We will show in the later class how why this U is added in more detail. But any econometric model, you will have this U or epsilon, which is a disturbance term, which is saying that the relationship between X and Y is not exact. So they showed this graph here, showing that all these data points, also called scatter diagram, these points. What are these points, by the way? Hello?
Professor, the value of income and consumption.
Yeah, each point is giving you first value for income, second value is
Second value for consumption.
consumption. If it was a exact relationship, then you would get a straight line. Okay, 1x, 1y, 1x, 1y. X increases, y increases. But in real life, when you collect data, you will see that that's not the case. We examined in the last class. Here, 1y, here, another value. X increasing, but y is decreasing here. So that kind of thing can happen, and we will capture that. So these points are coming from this data set. You see, so this is for over the years. The data 82, this year from 82 to 96. Here is consumption. Here is income from the real life data. Where do you get the data from? Where do you get the data from? Hello?
Yes, Professor. Real life.
Where you get the data from?
By sampling.
You can ask people. You collect data, or their published data. They're like World Bank, IMF. They have data, countrywide data, or people read survey and they compile the data, or you go ahead and you find the data, you do your survey and you find the data. Now the main problem here, okay, main issue here in econometrics. Let's go back. Look at this beta 1 and beta 2. What is beta 1? The intercept. What is beta 2? The slope. To draw a straight line, what do you need?
X and Y points. 2 points.
2 points. 2 points. If you know 2 points, you can draw it. In other words, when you draw it, you know the intercept, also the slope. If you know the intercept, you know the slope, can you draw the line?
Yes.
Yes. So to draw the straight line, the relationship between X and Y, you need to know beta 1 and beta 2. How is a straight line different from another one? A straight line is different from another straight line because either intercept is different or the slope is different, or both intercept and slope are different. Do you agree?
Yes.
Yes, Professor.
So drawing a straight line, meaning knowing intercept and slope. If you know intercept, you know slope, you just draw the line and then you can exactly tell. If you give a X value, you can give a Y value. First, this thing has to be clear. Here, you see they're drawing this line. Here, drawing this line. Obviously, if you have to draw this line, you need this intercept. Also, you need the slope. The whole point of econometrics is to find this intercept and this slope. The problem is nobody knows. Nobody knows the value of beta 1. Nobody knows the value of beta 2. If you don't know beta 1 and beta 2, can you draw the line? No. So whole point of the econometrics is to find beta 1 and beta 2 in such a way that you don't make big mistakes. Because let's say in real life beta 2 is positive. If you end up with a negative beta 2, what kind of line will you draw? Hello? Hello,
Yes, Professor.
Yes, Professor.
I'm asking, let's say in real life, beta 2 is a positive value, okay? But nobody knows what that value is. However, you end up with a negative beta 2. Then what type of line you will draw? Upward sloping or downward sloping?
Professor is downward.
So, are you making a big mistake or a small mistake?
Big mistake.
Suppose actually this is like this, but you have drawn the other way. Why did you draw other way? Because you got beta 2 negative.
Yeah.
So that's a big mistake. If actually the line is like this, the line is like this, but maybe you can draw a little bit upward sloping like this, or a little bit flatter like this. That's a mistake, obviously, but that's not a big mistake. But if you draw a line like from here to there, that is a huge, huge mistake. The problem is nobody knows actually what the intercept is and what the slope of that line is. Now, as the econometrics duty to find out the intercept and the slope. Remember, we talked about population parameters in the statistics review.
Yes.
Mu, sigma
Yes.
squared, mu. Nobody knows what mu is, but we need
Yes,
to
Professor.
uh, talk about mu. So what do we do? Hello?
Average.
Yeah. What do you do? If we need to know the mean of a random variable, what do we do? Have you looked at our review at all? Hello?
Yes, Professor. Can you please repeat the question?
Repeat the question.
Ask anything. I was just away for a while. That's why.
Huh?
I went to fetch some water. I was away for a while. I thought you were asking something.
Okay. So if you want to know the mean of a random variable, what we do is we collect sample and then we find the sample mean, X bar.
Professor, in that time we have there will be given x value and p of x or f of x, and after multiplying these two we can get the random variable of mean.
You get the random variable. I don't see what you're saying. I'm saying if you have a random variable with mean mu, okay? Now you want to know the mu. Is it possible to know mu?
Yes.
No. Then you did not listen to what we did so far in the class. The whole point of the estimation, this inference statistics, is the population mean, population parameters are unknown. So we resort to sampling distribution. We collect sample and we find the sample mean. So we try to talk about mu. Basically, what we have in hand is sample mean. But can you guarantee that sample mean equals population mean? No, nobody can guarantee that. But with some strong property of sampling distribution, we can talk about mu with the help of X bar. X bar is called an estimator of mu. Okay, so here is also, if you don't read the thing we are doing, it will be difficult to, this is one lecture is built upon another. So here what we are doing is a similar thing. Here beta 1 and beta 2, they are population parameters. the population intercept and the slope, which nobody knows. What is the job for econometrics? Econometrics will try to find something close to beta 1 and beta 2. So that is called estimation. What are you estimating? What are you trying to find? You are trying to find beta 1, you are trying to find beta 2. But it's not possible to find what actual beta 1 and actual beta 2 is. But there are ways to find estimators of beta 1 and beta 2. Like there is no way to find mu, but there is an estimator of mu like x bar. So what we will find is exactly not beta 1, but an estimator of beta 1. What we find will not be exactly same as beta 2, but which will be close to beta 2, an estimator of beta. If you know something close to beta 1, let's say here they did it, how? Obviously we'll learn as we go how we find these numbers. So an estimator of beta 1 they got is minus 184, and our estimate of beta 2 they got is 0.706. So if this is beta 1, estimate of beta 1, this is estimate of beta 2. Beta 2. Okay. So the slope coefficient, an estimate of that is 0.70. An estimate of beta 1 they got is minus 184. Are they actually equal to beta 1 and beta 2? Nobody can guarantee that. But we expect they should be pretty close to beta 1 and beta 2. Question? Hello?
Professor,
Yes.
Professor, can you explain the differences between exact and inexact again? Like
Which one?
there was exact and inexact. Like there was an equation y equals to beta 1
okay.
plus
Okay.
beta
So
2
exact
x
and
plus u.
inexact. Here is an exact relationship. Okay. Treat it as plus. Why is it an exact? If you give an x value, you will get an y value for a straight line. If it's a straight line, if you know intercept, if you know slope, if I give you x, can you find y? Hello?
Yes, we can find y.
If suppose you know the straight line equation, okay? Y equals 5 plus 3x. So if I give you x value, one x value, will you get a y value?
Yes.
Exact value on the line. Any x value I give you, you will get a y value on that straight line. Don't you?
Yes, Professor.
That is an exact relationship. So is exact relationship clear?
Yes.
Okay. Then what is an inexact relationship? Inexact relationship is like this. You give me an x value, you give me an x value, you will see that y value is not on that line. If you give me another x value, y value is below here, either below the line or above the line. The value, any x value, y value can be above the line, on the line, or below the line. That is an inexact relationship, not an exact relationship. Is that okay?
Professor, in this graph, is there a just relationship?
This is not an exact relationship. Why? Because any x value, will you be on this line? Why? No, either it's here or there or above or below, or maybe some values will be on the line also. Could be, but no guarantee that when you give me an x value, y value will be on the line. So that is not an exact relationship. Question.
Professor, can you explain the purpose of adding plus u again?
Which one?
Like in an exact value, there was like y equals to b1 plus b2x plus u. So can you explain the purpose of adding?
Can you speak little bit loudly? I cannot hear what.
No, there was an equation where it was written y equals to b1 plus b2x plus u.
Yeah.
Can you explain the purpose of u? Adding u.
Purpose of u.
Yes.
This u.
Yes.
So if you give me an x value, you will get a y value, okay? If you know beta 1 and beta, forget about this u. If let's say beta 1, beta 2, these are known. If I give you x value, will you get a u value, y value?
Yes, Professor.
Huh?
Yes, Professor.
Yes.
However, let's say I give you x value 20, you get a y value 50, okay? So that is on that line. So let's say this is 20, income 20, 50 is here. On the line is y equals 50. Okay. All right. That is coming from the exact relationship. Now, in real life, when you ask people, what is your income? 20. How much do you, it's not 50, let's say 15. So if x is 20, from the exact part, you get 15. So ideally, if the income is 20, that person should spend $15. However, if you ask him, he says, I spent $12. So this is 12. How do you get that 12 now? Huh? How do you get that 12? If so, x is 20. With your alpha and with beta 1 and beta 2, you should get 15, but you got 12. How do you get then? How do you say y equals 12 now in that equation?
There's some arrow.
You? What do you do?
Professor, is u unknown or known?
Huh?
U, is it unknown or known?
Let's say, let's say you have this exact number, okay? Exact part, which is saying if income is 20, consumption will be $15. But when you ask the person tells you that I spent $12. How do you write in that equation then?
By adding u?
Adding 2 or subtracting 3? Don't you see that you have to subtract 3
Yes.
to get 12?
Yes, sorry.
That is that u. Let's come to this point. Let's say with the exact part, the person is saying if income is 25, the person should spend $20. Okay? Income is 25. The exact part with beta 1 and beta 2, without u, the straight line is telling you if income is 25, consumption should be 20. But you ask the person who has income 25, is that I spent 23. How do you add that? Do you see the point here?
Yes, Professor.
So
the extra is
this
u.
part is telling you income 25. This part, if you add beta 1 plus beta 2x, you get 20. But so y should be actually 20. But when you actually ask, the person said, I spent 23. What do? You add?
Subtract 3.
$3. Whatever you got here, you add 3.
Add $3.
Professor, if I spend like less than that, if I get this, then it will be minus.
Yeah, you can be plus, you can be minus. It's a random variable. Remember, if it is normal, What is the range? Huh?
Minus infinity to plus infinity.
Yes. So it can be anything. If it's a normal, if it's a t, it can be from minus infinity to plus infinity, depending on whether the person is spending more than what the exact relationship is telling you. If she spends more, then you add. If she spends less, then you subtract. That is the inexact. Okay. But focus, however, here is estimation. The problem is beta 1, beta 2, they are unknown parameters like mu and sigma square. So we have to find a way to guess them. But this guess is not random guess. This is not wild guess. This is an educated guess. This will be a scientific procedure to find beta 1, beta 2. Actually, you will not find, but you will guess. Well, in a scientific method, you will estimate. To be exact, to be correct, you will estimate beta 1 and beta 2. We will learn 2 ways to find them. Okay, so that is the whole point, to find them, and then you can use it for other purposes, like prediction. What is prediction? Even though prediction looks like so okay, before prediction, there is this hypothesis test. I'll not explain too much. We will know as we go. Have you done any hypothesis test?
Yes.
So like test of mean, test of variance.
Yes, Professor, a little in.
Okay. So did you do test of mean?
Yes.
Did you do difference of means?
Difference. Yes, Professor.
Okay. So when you do a test of mean, what are you testing?
We're testing if the statement above the our topic.
Let's say you are testing mean.
Yes.
What will be now hypothesis?
If the statement is true.
If
the statement is true, like if my thesis statement is true.
Okay. Then how do you test?
If the mean is less than or greater than or equal to or close.
What is this mean? Okay, let me clarify the question again. We have so far seen population mean, sample mean. What mean you are testing?
The average.
No. What average? What is average? There are 2 types of means. For the so far you should know that there is this population mean, there is this sample
mean.
When you are testing, what type of mean you are testing?
Sample mean.
Sample mean. You are testing sample mean. Anybody else recall anything? Hello?
Yes, Professor.
Do you recall anything about testing a mean? Or population, difference of population means, or difference of variances? Actually, whenever you test, for now on, never forget, never ever forget. Whenever you test the population parameters. What did I say?
Test the population parameters.
You always test the population parameters. So when you test mean, what do you test?
Population
parameter. Let's say you want to know whether mean is mean age of our student is 20, let's say. So you are testing actually whether mu equals 20 or not. Never test whether x bar equals 20 or not. Will you remember this?
Yes, Professor.
Others?
Professor, can you repeat?
How many times? Okay.
I can't hear you properly because of
All
the
right, yeah, that's
connection.
fine. I'm just joking. Yeah, obviously. So, for now on, always remember when you are doing a hypothesis test, what are you testing? You are testing the population parameter. You are testing population mean. You are testing mu, or you are testing variance, population variance, sigma square. You never test sample mean or sample variance. Will you remember this? Hello?
Yes. Yes, Professor.
Never ever forget that you are trying to know population parameters. That's why you are testing the population mean or population variance. So you are testing population mean. What are you using to test that? You are using the sample information. You are using sample mean. You are using sample mean to test population mean. Will you remember this?
Yes.
You guys have already done probability statistics. Remember, you cannot forget this basic stuff. So here also we'll do hypothesis test. What are the population parameters here? Beta 1, beta 2. We will be testing beta 1 and beta 2. We will be using sample information. Similar. All right. Right now it looks abstract, but as we go and as we do actually we test, then you will see. Then you can do forecasting or prediction. It's kind of a big mouth saying, oh, we can predict. Actually, what it means is, if you give me an X value, I can give you a Y value. After we estimate beta 1 and beta 2, after we find beta 1 and beta 2, then if you give me a X value, I'll give you Y value. That is a starting point. That is a prediction for Y. All right. Obviously, if you know beta 1, if you know beta 2, any X value will give you an Y value. So that is prediction. And then we have, any question about prediction?
Professor?
Yes.
I have a confusion. Like, is it if we know beta 1 and beta 2, we can find Y, or if we know X, we can find Y?
No. Obviously, if you don't know beta 1 and beta 2, if I give you X, can you find Y?
It won't help. So we need to know all three of them to find Y, right?
First thing, the whole point of this X and Y you will get from the data, don't you?
Yeah.
Okay. But still, can you draw if you don't know beta 1 and beta 2?
No.
Huh?
No.
So what econometrics will do is, with the help of the data you collected, econometrics will find a way to find beta 1 and beta 2. Once you know beta 1 and beta 2, any X value you give me, I'll give you a Y value. Is that possible?
Yes.
Yes, that's possible. Because then you know how to draw the line. You know intercept, you know slope, you have drawn the line. Any X value, you will get a Y value. Other question?
Professor, how will we know beta 1 or beta 2? Like, will it be given?
How will you know it?
Oh, through X and Y? Like we have to find out the slope. So that's
Yeah,
how
you
we...
have to find out the intercept, you have to find out the slope. How do you find intercept and slope? That is the whole point of econometrics. That's what we are going to do mostly in this class. Probably we will do many other things, but the crux is we have to find a way to estimate beta 1 and beta 2. There are scientific methods to find them. But you have to wait a little bit. Not today. It takes time. Yeah, we'll go slow. Any other questions? Hello?
No, Professor, no.
No, no questions. So that is prediction. Then there is, if you do other things like policy purpose, you can control. What does it mean? It means the other way. Let's say you have already estimated beta 1 and beta 2. Now, let's say you have a target of consumption 4900. This is your target for consumption. You want to get this much, let's say $49,000 billion of consumption for the economy. Then you can find how much GNP or GDP the country, the economy should have. So, in simple words, is saying if you have a Y value, I can give you the X value. Is that possible? Hello?
Yes, Professor.
Yeah, why
Yes,
not?
it's possible.
If you say, oh, I need $49,000 billion of consumption for my people to survive, then I will say, okay, you generate then. I will plug that 49 here in the equation. I'll say, okay, generate $7,197 billion of GDP. If you can generate $7,197 billion of GDP, then you can have $49,000 billion of consumption for your people to survive. Okay. Question. Hello. That's called a control. If you give the Y value, I'll give you X value. Prediction. If you give me X value, I'll give you Y value. Any questions on that? Hello.
No, Professor.
No. In that case, can I ask, what is the? How do you explain the slope here? Do you see the slope here? Huh? The slope of this line. What is the slope of this line? Hello. What is the slope of this line?
Professor, can you move the arrow?
What is the slope of this line? Equation.
0.7.
0.7. Can you explain that? Hello. Can you explain that for me? Here, 0.7. Who can explain that for me? This is the slope of that consumption function. the slope is telling you what here?
For
If the
every unit of x,
For
for if x increases by 1 unit,
$1, let's say.
$1, then consumption will increase by 0.7064.
Yeah. So basically, what you are saying is, if your consumption increases by $1, if your income increases by $1, your consumption will increase by 70 cents. Okay, MPC is 0.7. How do you explain the other number? Beta 1 here? How do you explain that? The intercept? Hello? Nobody wants to explain, interpret the intercept? Huh? Nobody wants to talk? Some people already left. Hello? Can you hear me?
yes, Professor.
Okay. So this is an eye-opener for you guys. First thing, the intercept is saying if x equals 0, if income is 0, what is the consumption? Huh?
Of 180
Minus
184.077.
minus 184. What does it mean? Basically, it means nothing in that example. Can consumption be negative?
consumption. No.
No, Professor.
Theoretically speaking, what it's saying is if x is 0, income is 0, consumption is minus $184, which doesn't make any sense. Sometimes you will encounter that kind of issues in this econometrics regression analysis. Sometimes you will get nonsensical results. If it was a positive value, then it would make sense. Okay, but for us, we are learning. We can explain, theoretically speaking, if x is 0, y would be minus 184. And later on, you will see that regression will do only average analysis. I
But
repeat.
the consumption cannot be negative, right?
Yeah, consumption cannot be negative. So that's why I'm saying this particular example is leading you to a nonsensical beta 1. Plus, what I'm going to say right now is regression always does an average analysis. Always does an average analysis, and what it means, you will learn gradually. But just remember that regression will do only average analysis, not any individual analysis. Later on, you will see what it means. So I guess so far, the first chapter, we don't need these types of econometrics. Yeah, theoretical and applied, we know. Theoretical is beyond our syllabus. We can do only applied. We'll do applied. We'll be using the theories of econometrics in this class. So that's it about the first lecture. Maybe you have questions you can ask right now, what we did, or we'll move on to the actual regression. So to summarize, first thing is the theory, economic theory. Whatever the economic theory tells you, you grasp that, like consumption theory, Keynesian consumption theory. Keynes says income increases, consumption increases. But if income increases by $1, consumption increases by less than $1. then what you do is you try to write it in a mathematical form. Right, consumption depends on income. Then simplifying assumption, what we took is, let's say this relationship is linear. It could be quadratic, it could be logarithmic, but we just took it took the simplest possible relationship, linear relationship, a straight line kind of relationship. So then obviously if it's a straight line, you need to know two things: the intercept, the slope of the straight line. When you say it's a straight line, you want to know beta 1 and beta 2, the intercept and the slope. The problem arises when you see that even though it looks like it's a exact relationship, one x value will correspond to another y value and so on. But in real life, you see that the relationship is not exact. There is some randomness in that relationship. So we add a u in that relationship. Then the major part is to find beta 1 and beta 2, which is called estimation. To find beta 1, to find beta 2, which is not possible, but we estimate beta 1 and beta 2. We guess scientifically. Two methods will be used. One is called ordinary least squares method. Another method is called maximum likelihood method. These two methods are scientific, powerful, with good properties. You will know what good properties mean. Then if once you can do it as you can estimate, then you can do many things. One, hypothesis test. And there my caution is, you have to always remember that we are going to test population parameters with the help of sample information. Then we can do prediction, which simply means if you give an x value, I'll give you a y value. To begin with, there are many other things obviously in there. Another one is a control for policy purpose. What can we do? If you give me a y value, I'll give you an x value. So that's it. Okay. Then we move on to the estimation thing. Estimation will be rigorous, very rigorous estimation method. It is called also regression analysis. Through regression analysis, we will estimate beta 1 and beta 2. There are some theoretical issues, regression versus causation. Well, we will not go in there, whether regression means causation. But there is one thing which is, I told you guys before also, which looks similar but not same, is called correlation. Have we talked about correlation? Little bit? Hello?
Sir, we know about the
correlation? Yeah. What do you do in correlation? What is the correlation coefficient? It's telling you.
It means two objects have some positive relationship or negative relationship.
Okay. There's a relationship between two variables.
Yes.
How strong the relationship or how weak the relationship? It can be positive, it can be negative.
Yes.
Anything else? Anything else you want to know? You want to tell about correlation? A lot of more things to say. Number one, correlation coefficient ranges from -1 to -1 to +1. Correlation coefficient ranges from -1 to +1. If you get a correlation coefficient close to -1, that means what? Is the relation strong or weak?
It's strong.
Relation is very strong, but the direction is opposite. If one goes up, another goes down. If correlation coefficient is close to 0, what does it mean?
It's weak.
Very weak. If it's a negative value close to 0, it's weak but opposite. If it's a positive value close to 0, it's still weak, but it's a direct. One goes up, another goes up, but very little. If it's close to +1, it's very strong, and both the variables are going in the same direction. Anything else important thing to know about correlation coefficient? Correlation measures the linear relationship. Correlation measures what?
Linear relationship.
Linear relationship between two variables. Non-linear relations. What should be the correlation between x and x squared? What do you think? Hello? Correlation between x and x squared. What do you think?
Both are random variable.
X and x squared. What do you think about? What do you think? Any idea?
I think it's
If x increases, what happens to x squared? Do you guys see the basic point of these relationships? These are variables, okay? So if I say x and x squared, what do you think?
It depends on if x is like between 0 and
I cannot see what you're saying. I cannot hear. Sorry. Can you speak a little bit loudly?
if the x is the value is between 0
1%.
and 1.
If x is the value of x is
It's between 0 and strong relationship. If it's bigger than 1, so it has a strong positive relationship. Hi, Professor, can you hear me?
what will be the correlation coefficient? Please, those who are not talking, can you mute yourself, please? I'm hearing a lot of noise. I don't know where from. Okay, Manisha, So what are you saying? Correlation coefficient will be high or low or what?
I mean, if the x value is between 0 and 1, so it have a strong correlation,
Strong correlation, positive or negative?
negative. If it's, the value is bigger than 1, so have a strong positive relationship.
Okay. So how about if it's negative? If it's negative. Okay.
No, it should be positive if it's bigger
Yeah,
than
but
1.
x can be negative
value.
as well. If x is negative, then what happens?
If x is negative, oh yeah. If x is a negative value, so when
Okay. So the lesson for us is correlation coefficient doesn't care about non-linear relationship. Okay. It only captures what? Linear relationship between two variables. Do you know what a linear relationship between two variables is? What it means? Hello? Linear relationship between two variables. Hello?
it means either in the positive relationship or negative relationship.
Yeah. So how do you write it in equation? A linear relationship? Can you write it in an equation?
Equation,
Yeah. Have you thought of it? Linear relationship?
maybe.
Okay, you think about it, okay? But correlation does not say which one is independent, which one is dependent. The major difference, correlation just says these two variables are either going in the same direction or in the opposite direction, linearly speaking. In the regression, hello, who is speaking? In the regression analysis, however, you have clearly defined X, here in our example, income is the independent and Y, which is our consumer expenditure, is the dependent. So regression analysis clearly says which one is independent, which one is dependent. And the correlation analysis, there's nothing like dependent or independent.
Professor, can you say again because there is a lot of noises?
Where is it coming from? Please mute yourself.
Professor, I think you are the host. You can mute everyone and then.
Yeah, Manisha, you yeah. Everybody, please mute yourself so we can listen to it. Okay. So what I'm saying is, in a correlation, you don't know which one is dependent, which one is independent. You don't care. You basically do a relationship between two variables randomly. Variables, and you are measuring the linear relationship, degree of linear relationship between two variables. In a regression analysis, you clearly define the independent variable and the dependent variable. Later on, you will see that independent variable will be non-random. Dependent variable will be random, stochastic. You will see later on. Okay. Data. So when you do the regression analysis, obviously, or even correlation, you need the data. Now, this is a chance for you guys to know what type of data are there. Basically, these three types. Other types I will not discuss. You learn it from statistics. Time series data. So three types: time series data, and cross-sectional data, and pooled panel data. Time series data is pretty straightforward. Time series data means over the period. So let's say GDP over the period, over the years. Let's say you start from 1972. GDP in 1972, GDP in 1973, in 74, 75, and so on. That is a time series data. Time series data can be yearly, can be quarterly. Quarterly means what? How many quarters are there in a year?
4 quarters.
Huh?
4.
Quarters.
2 quarters, 3 quarters.
4.
4, Professor.
4 quarters. Quarter means quarter, the very word quarter is telling you there will be 4 of them. So time series data can be quarterly. So you are measuring in 3 months. Like GDP, you can do it quarterly also. Some countries do that quarterly GDP. And also can be monthly, can be weekly, can be daily. Do you see daily data in some areas? Huh?
Yes. Yes,
Which-
Professor.
Which area?
For example, the stock market.
Exactly, stock market data. They actually change from minute to minute. At least daily they are updating. So that's a daily data. There's also times there's a high frequency, daily you are getting data. Yearly data is not high frequency. Once a year you are getting it. So that is time series data. Cross-sectional data. Cross-sectional data means at one point of time across areas. At one point of time across areas. Let's say GDP of all countries for the year 2019. How many countries are there? Do you know right now in the world how many countries, sovereign countries are there? Huh? Any idea? Hello?
No, Professor.
No ideas. Okay, I don't have any idea either. But if you look at World Bank data, they are giving data for maybe more than
195.
Huh?
195.
195. So in the World Bank data, let's say for the year 2019, you are looking at the GDP of different countries. So you can see 195 data points, GDPs of 195 countries. Or you can say, I'll look for cities of my country. How many cities are there? Big cities. Let's say you have 10 metropolitan cities in your country. So you say in January, in the month of January, I would like to know the demand for meat in different cities. So that's a cross-sectional data. For a point of time, you are looking at the data across areas. So 2 types. If you know these 2 types, you know the 3rd type. First type is time series over the period. Another one is across the countries or across the cities or across the places, other villages, so on. Then when you pull these 2 types, time series as well as cross section, you stack in one column. That is a pool data or panel data. So how you do it? Let's say you are looking at GDP for 20 years across the countries. So let's say you start from 2001. 2001 GDP of Bangladesh, India, Pakistan, Nepal, Bhutan, Vietnam, Syria, Sri Lanka, Myanmar, all those countries. So you stay. Then you have 2002. Again, you have GDPs of all these countries. So you are stacking. You are considering time series and cross section together. So these are the data you will be using. Remember, these data you have to use to find beta 1 and beta 2. That's why you should have some familiarity about the this type of data. When you do survey, mostly our students doing survey. Basically, you are looking at cross-section data. Here they are showing this GDP, blah blah, time series data. I'll not talk about ratio scale as you go, you know. Okay, so data type. Do you have any questions about this different types of data? Hello? Remember, you will be using some sort of data, either cross-section or time series or panel, both types together.
Professor,
Yes.
like we have 10 minutes left. Can we end the class here? Like,
Oh, you want to end the class now? Why?
We have 4 minutes, Professor, not 10.
Huh?
We have 4 minutes left.
We have 4 minutes now.
Yeah, the class ends at 6:20, right?
4 minutes.
Yes.
30.
Do you have only 4 minutes?
Professor, now we have 3 minutes.
3 minutes. Okay. In that case, we call it a day for today. So don't forget, we have our quiz, and until today, it will be in our syllabus. Okay?
Yes, Professor.
All right. Thank you then.
Thank you, Professor.
Sure. Hello?
Yes.
Until today's lecture. But maybe we have another class.
Yeah. So what